Hello everyone, welcome back to the training. I hope I'm clearly audible to all of you. Guys, can you confirm? Yeah, okay. So in the session yesterday, we spoke about the concepts of routing and we looked at how static routing can be configured on the devices. And we tried out a simple topology having first just two routers, then we looked at a topology which had three routers. Today we are going to learn about something very amazing, which is default routing. So I'll share my screen of Cisco Packet Tracer. We'll quickly talk about default routing. So here we are just chatting right now. So we are about to start the session. So I was talking about the default routing, and default routing is a mechanism where we uh, tell the device that there is only one gateway. There's only one gateway for all the indirectly connected networks. Okay. So in a situation where, let's say, all of my traffic, which is supposed to get delivered to some other branches or some indirectly connected networks, has to go through from one router only, I can implement default routing in such situations. Let's talk about a simple scenario. I'll assume that this middle router is my headquarter routers, and two of my branches are connected to it, branch number one and branch number two. Now, any traffic that has to go from branch 1 to branch 2 needs to pass via headquarter. Okay, so I'll connect some devices here with router number 1 and router number 2, assuming that these are my branch setups. And I will connect all these devices together. We'll assume that this network is 210.1.0/24. This one here is 210.2.0/24. Between my router one, the branch router and the headquarter router, I will use, let's say, 12.10.1.0/30. And here I'll use 23.10.1.0/30. Okay. So first thing is putting IP configs. So I'll get started from my middle router, the router 0, CLI. I'll say no to the question. Enable config T, host name, headquarters. On the interface FA0/0, I will configure the IP address as 12.10.1.1/30. So /30 subnet mask is going to be 255.255.255.252. No shutdown, exit. On the interface FA0/1, IP address will be 23.10.1.0/30. So 23.10.1.1/30 subnet mask, no shutdown, exit. Then yesterday we also spoke about DHCP relay configuration, for which I am going to create a DHCP pool on this middle router only. All my DHCP pools are going to be defined on this router, which we will consider as DHCP server. So I'll create the two pools, IP DHCP pool A for my first network 210.1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0/24. 1.0 with the default router address as 210.1.1. Exit. Similarly, I will configure another pool, IP DHCP pool B, for the network 210.2.0 with a gateway address of 210.2.1. Exit. Now I can continue further to configure IP configs on my router number 1. So I'll take the access of router 1. I'll say no to the question. Enable config T host name branch 1 interface FA0/1 IP address 12.10.1.2/30 subnet. So 255.255.255.252. No shutdown. Exit. FA0/0. This is connected to the LAN network. So I'll configure the IP there as 210.1.1/24. No shutdown. Exit. I'll continue to router number 2, which is my branch router 2. So I'll take the access, say no to the question, enable config T host name BR2 on the interface FA0/0. I'll configure the IP address as 23.10.1.2, 255.255.255.252. No shutdown. Exit. On the interface 0/1, I'll configure the IP address as 210.2.1/24. No shutdown. Exit. Guys, we have configured DHCP pools on the middle router for this network as well as this network, right? On my router number 1 and router number 2, I'll have to specify who is my DHCP server using the IP helper command. I'll go to my router number 1. I'll go to the LAN interface, the interface which is connected to the LAN, which is interface FA0/0, and say IP helper address 12.10.1.1. Exit. Similarly, on my router 2 also, I will go to the interface FA0/1, and here I'll say IP helper address is 23.10.1.1, which is my router number 0, the middle router. This is what we have done yesterday also. After this much of the configuration, we looked at configuring static routing. In this case also, we will have to configure static routing. But on the router number 1 and router number 2, I will configure default routing. Let me know if you understand this. Can I say that router 1 and router 2 have only one exit point, which is router 0? Or there is only one possible next hop for all the networks, which is router 0. Can I say that? Even if let's say there are two more branches, branch 3 and 4, and these branches are connected with router 0 like this. So even to reach the branch number 3 and branch number 4 also, my next hop will be router 0, correct? My question is, can I say that all the branch routers will be able to communicate with each other only via the headquarter router, which is the middle router? Yes or no? Right? So on such devices, we can configure default routing. How we will configure it, let's understand. First, what I'll do is let me just remove these devices. And first thing that I'll do is I'll configure my middle router. Can I configure default routing on middle router? No. Why? Because for 210.1.0, the next hop will be R1. For 210.2.0, my next hop will be R2. Correct? So on the middle router, I have to configure static routes. I'll say IP route 210.1.0 255, 255, 2550 with the next hop as 12.10.1.2, which is my router number 1. Okay. Similarly, IP route 210, 2.0, 255, 255, 2550 with the next hop as 23.10.1.2. I have added static routes on the middle router, but on R1 and R2, I'll configure default routing. Let's see how we do that. We'll say IP route, but instead of defining any network ID, I'll use 0.0.0.0. 0.0.0.0 means it can be any network. Then I'll put a space and again I'll type 0000, which also means it can be any subnet mask. So any network with any subnet mask can be reached via the next hop 12.10.1.1. I need not to specify all the networks one by one. I just need to give one single command which will tell my router number 1 to forward all of its traffic to the middle router if it doesn't know about a particular network. Make sense? After adding this default route, I will check my routing table. What is the command for checking routing table on router, guys? Show IP route. So when I check show IP route, I can see a default static route is added. S represents it was added statically. Asterisk represents that it is the candidate default. Okay, so a default route is added via the next hop 12.10.1.1. Similarly, I'll go to my other router number 2. I'll put a default route from here also. 0.0.0.0.0. Next hop will be 23.10.1.1. Show IP route. We can see the default route is added successfully. Now let's assign IP addresses to these end devices and let's try making them communicate. So like we discussed yesterday, the first might fail. You can try again. Yeah, now it's successful. PC1, desktop IP, DHCP. Successful. PC2, desktop IP, DHCP. Let's try again. There you go. Then PC3, desktop IP, DHCP. Perfect. Now I'll try to ping my other network from my PC0. Ping 210.2.2. We can see we are getting the replies. Similarly, I can ping 2.3. And we can see the replies are there. That confirms the connectivity is also established. That's how the default routing is configured, guys. Let me know if you have got any questions or doubts in this. Yep, sure. If you guys don't have any question, then please take your time to try this quickly. And then we will be speaking about dynamic routing protocols. Sure, guys, the command for adding a default route is IP space route space 0.0.0 space again 000 and then the next hop IP address. Let's take 5 more minutes and try to complete this. And after that, we'll have a quick introduction to dynamic routing. Yes, Sayed, this is the configs for IP DHCP relay. First of all, configure DHCP spool on the middle router and then put this configuration on BR1 and BR2. The first set of 0000 is for the network ID, and the second one 0.0.0.0 is for defining the subnet mask. And third value, which is 12.10.1.1, is your next hop router. Okay, let's understand DHCP relay configurations again. What we have done is we have created DHCP pools here on the headquarter router. As you can see, pool A is for 210.1.0, pool B is for 210.2.0. So for DHCP IP allotment, this server is going to be used, right? I need to tell router 1 and router number 2 that when they receive discovery message from the PCs, they are supposed to take help from the router 0. So how do we inform these routers? We go to them and we get into the interface which is connected to the LAN network, like interface FA00, and we set IP helper address as the IP of the router on which DHCPs are configured. So 12.10.1.1 is nothing but IP of this middle router, which my R1 can use for getting help about IP address. Does that make sense? Correct. Router 0 is configured as DHCP server. IP helper address is the information that we are giving on router number 1 and router number 2 to let them know that when DHCP is something which they need, they can reach out to router number 0 on the IP 12.10.1.1 or 23.10.1.1. Not yet. I was waiting for you guys to complete. So now the next thing that we are going to look at is dynamic routing. Like I said earlier, in CCNA, we only discuss internal gateway protocols, and we'll be speaking about RIP, EIGRP, and OSPF in the session. Today, the topic of discussion is going to be RIP protocol. Let's understand how RIP works, what exactly it does. Before we jump on to RIP, I would quickly like to tell you how dynamic routing works. In the case of dynamic routing, we really don't have to add any networks manually. The exchange of network information happens dynamically. Let's say we have this small topology where the first network is 210.1.0, 210.2.0, and between the router it is 12.10.1.0/30. In the case of static routing, what we had to do was we had to add this network in R1 and add this network in R2. Correct? That's how we configured static routing. But in the case of dynamic routing, we just add the directly connected networks into the database and they automatically exchange the routing information with the connected peers. Make sense? We have a good question here. Is RIP part of CCNA or not? No, it is not. I explained this yesterday also, I believe. RIP and EIGRP are not discussed in CCNA. RIP is not even used nowadays in production networks, but we do discuss RIP a little bit to get the idea of routing and to at least know what exactly it is, right? So that in future, let's say someday, if you have to work with it for some reasons, you should be able to understand how things are working there. That's the only reason it's not a part of official content. So we discuss it just to make sure that you all are well aware of these routing protocols. Rahim, we are discussing dynamic routing only. I'm explaining that only. Yeah. So I was saying that dynamic routing, in the case of dynamic routing, they exchange the network information dynamically. You don't have to install all the routes one by one. Now, in the case of static routing, we had to do this manually. So if I have a big network, let's say having 20 networks in it, it's going to be a very hectic task to add all the 20 networks one by one into the scenario, correct? So in a situation where your network is big, you go for dynamic routing protocols as they can help in easing the process by exchanging the configuration and the network details dynamically using some protocol. One of them is RIP. RIP stands for Routing Information Protocol. Then another one is EIGRP, which stands for Enhanced Interior Gateway Routing Protocol. And we have OSPF, a very important one, Open Shortest Path First. Today, our focus is on understanding RIP. So let's discuss how RIP works. RIP is a dynamic protocol, so it doesn't want you to put the networks manually one by one onto all the routers which are connected. It can do the job of exchanging routing details automatically with the help of some exchange of messages which will happen between all of the RIP configured routers. There are few characteristics related to RIP that we have to understand before we can look at the process of configuration of RIP. So we'll speak about them quickly. We'll try understanding what are these processes. I mean, what are these characteristics related to RIP that we should be aware of. All right. So in the case of RIP, first of all, we need to understand RIP, which stands for Routing Information Protocol, is something which we use for configuring dynamic routing and is an open standard protocol. Can anyone explain me in the chat what does it mean to be an open standard protocol? Perfect. Like most of you mentioned, it is something which can be used by all the vendors. So there are different manufacturers of network devices. There is Cisco, there is Juniper, there is Huawei, there is F5, Palo Alto, Checkpoint, and so on. So multiple vendors are there who contribute in manufacturing network devices. So being an open standard protocol means it can be used on all of those vendors. It is not specific to any particular vendor. Okay. For example, some protocols in networking are Cisco proprietary. That means they can only be used with Cisco devices, not the other devices. But RIP is an open standard protocol. That means it can be used with all the other vendors as well. Then RIP is available in two versions. It is available in two versions. First version is classful and the second version is classless. What does it mean to be classful and classless? Let's understand. When we say that a particular protocol is classful, then that means it will not share subnet mask information. The subnet mask will be considered as default subnet masks. For example, we just tried a topology where R1 and R2 were connected with the network 12.10.1.0/30, correct? Now, if I will advertise 12.10.1.0 without the value of subnet mask, so my router will understand it like this. It belongs to class A. So for class A, it is a /8 network. That means this network advertisement should be treated as 12.0.0.0. This is how classful networks operate. Okay. On the other hand, when we speak about classless, they share the network updates along with the subnet mask information so that appropriately the networks can be added into the routing table of the other devices. Are we clear about this? So the very first difference between version 1 and version 2 is that version 1 is classful and version 2 is classless. Okay. Then moving ahead, we have to understand that RIP uses the metric as hop count For example, if R1 is connected to R2 and connected to R3 and connected to R4 and then connected to R5 like this. Assume that the bandwidth or the speed here is 100, 100 and 100 Mbps, whereas on the other side the speed is only 10 Mbps. So according to you guys, which one out of these two routes are better? I mean, which one is the better one? R1 to R2 to R3 to R5 or R1 to R4 to R5? What makes you say that the second one is the better one? We have a lesser speed here. How can you say it is the better one? Exactly. Because RIP considers hop count as the metric. RIP will understand that this is a better path and will install this one into the routing table. Clear? Because here we have lesser number of hops, we will consider this path as the better path as compared to the upper one. Even though the upper one might help me reach the destination with a better speed and with lesser time, still I will consider this one as the better path. Then what if, let's say, we have same number of hops on both the sides? R1 is connected to R2 and R3, and both of them take me to the destination R4. Now what do you think? Which is the better path? Here is the diagram. I'm hoping that my screen is visible. I have said earlier also that if you guys can't see my screen, try to rejoin the sessions. Guys, this is the diagram. Is it not visible? Okay, perfect. So now as the diagram is visible, what do you think? If I have to go from R1 to R4, which path is better, R2 or via R3? They both are same, right? So what will happen in this situation? In this situation, equal cost multipath is something which is used. Because the cost here is equal as the number of hops, if you count 1, 2, 1, 2, the number of costs are equal. So that's why we will consider both of the paths as best routes and we will load balance data. This is an example of equal cost load balancing. Clear, guys? In this situation, the traffic will be routed over both the available paths one by one. Like if I have 10 packets, so one here, second here, third here, fourth here, 5, 6, and so on. Moving ahead, there is a concept or a value called administrative distance. Let's understand what it is. administrative distance of RIP routes is 120. Now the question is that what is this administrative distance, right? Administrative distance defines the trustworthiness of a particular information. Lesser the administrative distance, more the preference. Okay, so different routing protocols will have different administrative distance values. In case, assume that R1 can reach R5. Assume that there are multiple routers participating in the path, but R1 can go to R5 either by using RIP or by using static routing. So which information will I trust more, or which information will I rely more upon? I will rely more on the static routing information. Why? Because the AD value for static route by default is 1 and the AD value for RIP routes is 120. So we can see clearly this is much lesser than 120. That's why I will prefer the static route information more. Is it clear to all of us? Perfect. I'll move these notes a little bit so that I can add more details here on the page. Yeah. Another thing to know about RIP is that a maximum of 15 hops can be connected in a RIP domain. Ankush, there is no preference value. I was saying that if AD is less for a protocol, we will prefer it more. Like in this case, static routing has a lesser AD, so we will prefer that route more. Clear? Yeah. So maximum of 15 hops only can be connected with with RIP, which means a total of 16 routers. Assume you have your router number 1 here. So your first hop will be routed 2, correct? This is my first hop. Similarly, router 3 will be my second hop. So I can connect such 15 hops only with RIP configuration. And if you will try to calculate, it's going to be your router 16, which will be your 15th hop. Beyond that, RIP will not be able to learn the networks or share the information. It can only work up till 15 hops. These are few reasons why we don't use it in production environment. You see, we cannot add more than 16 routers. The AD 120 is so high. Then another thing is that RIP updates, or we can say RIP sends periodic updates on multicast address 224.0.0.9. This is used by version 2 only. The version 1 only broadcasts. So multicast address 224.0.0.9 every 30 seconds. What does that mean? Okay, what is the multicast communication, guys? One to many, correct? So what happens when we connect multiple routers together using RIP? They participate in the multicast group 224009. So R1 will send periodic updates. R1 will send periodic updates to R2 and R3 using this multicast IP address, and it will do it every 30 seconds. And not just R1, R2 also will do the same, R3 also will do the same. And these periodic updates are the complete routing table of the devices. So R1, R2, R3 will exchange their complete routing table with each other every 30 seconds. Make sense, guys? Now, even if there is no change in their routing table, if there is no new information, still every 30 seconds, this information, every 30 seconds, the complete routing table will be shared with the connected peers. Any questions? So every 30 seconds, R1, R2, R3 will share their routing table with each other on the multicast address 224009. So when we send it on the multicast address 224009, all of the routers which are configured with routing table, uh, which are configured with REP, will receive these updates. We have got a question. Is it a disadvantage? Yes, a very big disadvantage, like Nicholas replied. It's going to utilize a lot of bandwidth. I don't have any new thing to tell you, but still, after every 30 seconds, I keep on sharing a lot of information with you. Do you think it is useful? No, right? So, the periodic updates of a complete routing table is not something which is very good for a network performance. Then we have classful and classless differentiation. Classful version is your version number 1, which shares the routing information without subnet mask information. So the default subnet masks are considered for the network. But classless version shares network updates with subnet mask information, making it more precise. Clear, Michael? Perfect. Then finally, we'll speak about the timers which are used by RIP. First of all, every 30 seconds, we are sharing the periodic updates. So yeah, that's your hello time. Then we have got an invalid time in RIP, which is of 180 seconds. Assume that R1 and R2 are connected with the RIP. Okay. R2 is sending the periodic updates every 30 seconds. But R1 is not doing so. R1 is not able to send the periodic updates. So after the completion of 180 seconds, I will consider R1 as down. Clear? And I will assume that this router is no longer reachable. Then there is flush time, which is of 240 seconds, which includes 180 seconds of invalid time plus another 60 seconds where we wait and still assume that there is a possibility that R1 might come up again. Okay. But after the completion of this flush time, which is another 60 seconds and a total of 240 seconds, we will remove all the routes related to R1. Let's say R1 was helping me to connect with 50 networks. So after completion of 180 seconds, I will assume that R1 is down. Then after another 60 seconds, I will remove all those 50 networks from my routing table because the R1 which used to help me to take to those 50 networks is no longer available. Clear guys? So flush time means after what time we will flush out the information related to a device. Yes, it is standard for all the vendors. It's going to stay same. Then we have another timer called hold down time, where basically these are another 80 seconds, 180 seconds, sorry. This is the time when router will try to find an alternative. It will try to look for some another option which can help me to possibly take to those 50 networks which were connected to R1. Make sense? So we'll try finding out some alternative. We'll try to look for someone else who can possibly help me. If we can find it, then great. If we cannot, then we simply lose the information of that particular network from the routing table. Any questions or doubts regarding any of the characteristics mentioned here? Yes, if the device is off and not able to send any updates, then also we will consider it down. Yes, correct, Sayed. After completion of flush time, your routing information related to that device will be removed. Yes, after completing invalid time and the flush time, we take another 180 seconds where we still do the processes, but we try to find for some alternative which can possibly help me reach the destinations. Any other questions? Routing information. Routing information will be removed after 240 seconds. The last 180 seconds is for the router to settle down. We can say it is a timer in which router will be looking for some alternative options. If it finds something, then great. If it doesn't, then it simply keep on operating with the available information. Okay. How the router will find if all routing information to network is deleted? Then we cannot find any option to reach the destination. That destination becomes unreachable. Static means one here. Basically, this is the AD value. AD value for rep is 120 and for static routes is 1. AD is basically the administrative distance, and like I said, it is used for finding out which information is more trustworthy. Any other questions here? Yes, Sham, for the devices or the networks which are directly connected to us, we'll find an AD value of 0. Yes, Michael, any router which will be configured with RIP will automatically become a member of this multicast group 224009. So anytime one of my router will send information on 224009, it will be received by R2 and R3 both. That's how multicasting works. Remember, we have spoken about it one to many. So R1 will give it directly to R2 and R3 by sending it on this address. Any other questions or doubts before we get on to the lab part? All clear, all well so far, whatever we are discussing in CCNA. Any questions, any doubts, any queries, anything? AD value is something which is predefined for different protocols. We don't have any rules or any method of finding it out. It is going to be 120 for rep and 1 for static routes. So these are predefined. Ankush, don't get confused between AD value and the number of hops. That's about the number of hops. That's a different thing. AD value is a different thing. 15 is the total number of hops that I can connect with a rep. AD defines the trustworthiness of a particular information. Make sense? Yeah, perfect. Awesome, great. So now we'll take a short 10 minutes break. And guys, I hope you guys are enjoying this pre-CCNA program. We try to do once every year. Like every year, we bring out one CCNA training for free for people who want to learn networking or want to explore networking. And we wish to keep on doing that, but that will only it will only get motivated if you guys will enjoy it, right? If you will learn out of it. So that's our main purpose. That's our main motive of conducting these free CCNAs. So earlier also I've shared one link where you can paste your feedback. You can tell us if we are doing good or not. And I'm putting it again in the chat today. I'll really appreciate if you can take out 2 minutes and put your review there about the training. And then after 10 minutes, we'll be getting back onto the lab and we'll be looking at the practical configurations of RIP. So if you are enjoying this content, if you are liking what we are doing, then I will really appreciate if you can take out some time to write about your experience. So this is the link that I'm pasting in the Telegram group. You guys can write about your experience here. Thank you so much. Yeah, Sham, definitely. Anyone who is regular in the training and is participating will definitely receive the course completion certificate. So need not to worry, be rest assured about it. All right, so let's continue. I'm hoping everyone must be back from the break. We are good to start. I'll drop a message in the group as well. We are starting now. Yeah, so let's begin. We looked at some basic characteristics of RIP, and now it's the time for looking at the lab part and see how the configuration of RIP protocol can be done, right? In the previous examples, we have discussed uh, how static routing works. And today we are looking at dynamic routing. So I'll show you how different it is and how amazing it is. It doesn't require you to add all your routes manually. It just wants you to advertise your directly connected networks. And then the remaining exchange of network details will happen dynamically through the protocol. No, screen is not yet shared. I'm sharing it now. And I was just going through the reviews. So thank you so much, everyone. I saw great reviews, great words from all of you. Thank you so much. I'm really glad that you guys are liking the training. And I'm pretty sure that if you will continue with the sessions, you will learn something amazing out of it. And we all will learn together, right? So let's continue the learning process. Let's understand how to configure rep in a given scenario. I will create a small topology, two routers first, and will add two switches and some end devices. Connect the cable like this. Here the network is going to be, let's say, 192.168 1.0/24. Here we have 1210 1.0/30. And here we have 192.168 2.0/24. First of all, I will configure the IP addresses on my routers. I'll go to the router, CLI, say no to the question, enable config T, host name R1. On the interface FA00, IP address is going to be 192.168 1.1 255 255 2550. No shutdown. Exit. On the interface FA0/1, IP address is going to be 1210 1.1/30. No shutdown. Exit. Then I will put DHCP pool configuration IP DHCP pool A for my network 192.168 1.0 255 255 default router address 192.168 1.1. Exit. DHCP pool is also created. I'll close this. Go to PC0 desktop IP DHCP. PC1 desktop IP DHCP. Then I'll go to my next router, router 2, and configure this one also. Say no, enable, config T, host name R2, interface FA 0/0, IP address 1210 1.2/30. No shutdown, exit, interface FA0/1, IP address 192.168 2.1/24. No shutdown, exit, IP DHCP pool A for my network 192.168 2.0/24 with a gateway address as 2.1. Then I'll go to PC2 desktop IP DHCP. PC3 desktop IP DHCP. Once the IPs are configured, my job is to make this network communicate with this one, right? For which I am going to configure rep. Let's understand how rep is configured. Very basic and simple configuration it is. Router rep version 2 network 192.168.1.0. That's my directly connected network, right? This is the one connected to me. So network 192.168.1.0 and network 12.10.1.0. Exit. That's all what I have to do. Similarly, I'll go to the second router. I have to just add my directly connected networks. Router rep version 2 network 192.168.2.0 network 12.10.1.0. And we are done, guys. After this, if I go and check my routing table, show IP route. So we can see it has automatically learned about 192.168.2.0. Do you see that? Then what is the AD administrative distance for that route? 120, correct? And what is this one representing? It is representing the number of hops. Clear, guys? Similarly, if you go to router 2 and check the routing table, show IP route. We have a rep route for 192.168.1.0. 120 is the AD, 1 is the hop count. Sure, Sayed. This is a situation where router 0 is connected with this network, router 2 is connected with this network. Now we have configured rep on R1 like this. We added the commands for rep by saying router rep. We specified we want to use version 2 and we added both the networks that we are using. The network 192.168.1.0 is what I am connected to, as well as 12.10.1.0 is what we are directly connected with, right? Similarly, on R2, I did the configuration of rep. I said router rep, I want to use version 2. I'm connected to these two networks directly. I added them. And after that, automatically, they will exchange the remaining routing information with each other. So R1, router 1 will give information about 192.168.2.0 to router 0. And router 0 will give information about 192.168.1.0 to router 1. Here we can see that. R represents rep. As you can see in the table here, R defines rep. Okay. Once that is done, we can test the communication also. I'll go to PC0 and I'll try to ping 192.168.2.2, which is my PC2. So let's see if we get any replies. That's how easy and simple is configuring rep. If you have got any questions or doubts, you can let me know. I'm sharing a lab guide for this one as well so that you can practice. Yes, Sayed, take your time, guys, to practice the same. And once you are done, you can drop a done message in the chat box here in the Telegram group. That's okay, Ashish. If you are not using DHCP and your communication is up, then also it's fine if you are using static IP configurations. Our purpose here is to learn how to use rep. So if your communication is working, that means the rep is configured correctly. Michael, make sure you are shutting down your router before you add NM2FE. Your router should be off when you are adding NM2FE module. Once the module is added, you can start your router. Okay, I'll show you a quick tutorial of that, Michael. If you wish to add a new module, what you have to do is you have to take the router, click on it, shut it down, and add like this. Click on it and drag it to the slot. Then start your router again. Now, when you will start your router, you have four ports on it. Two ports are going to be the default ports, and two are the additional ones that you have added. Okay. No, I have in this lab, I have configured DHCP pools on both the routers. So I don't need IP helper command, as for this network, the DHCP pool is available here. And for this network, the DHCP pool is available here. DHCP relay configuration or the IP helper command is required when there is one server which is having all the DHCP pools, right? So in this situation, I have configured it on both the routers individually. We have a question that why do we require 12.10.1.0 network? First of all, this is required to connect router 0 and router 1 together. Okay. So to make R0 and R1 communicate to each other, we need some IP connectivity for which this network was created. Now, inside RIP also, this is advertised, if you see, so that they both can connect with each other and can share their information, right? So that's the medium of connectivity between R0 and R1, right? 200, 190 to 168 1.0 is my LAN network. 190 to 168 2.0 is my LAN network of R2. If I just advertise these two routes, I'll not be able to connect with the other router. So to make this connectivity, first of all, I need 12.10 1.0 to be added inside RIP. Does that helps, Nicholas? Yes, Nicholas. To make the connectivity up with the connected neighbor, we need to advertise that network as well. Sanju, we are configuring version 2. So that means it's a classless network. Sure. First, we created the DHCP pool Then we created the rep configs. Okay, we have question, why are we not using network mask? Sanju, that's not required in case of rep. So it will automatically pick it up from the interface configurations. It's a great question here, that why we don't use a subnet mask and rather we use wildcard mask. So subnet mask represents the network bits as 1 and host bits as 0. And wildcard is inverse of that. So we haven't discussed it yet. We'll speak about it in the coming session. At that time, I'll let you know how basically they are different and what it looks like. Yes, track very well mentioned that classless allows VLSM. Any other questions or doubts regarding the lab that we tried? Okay, I think then we all are good with the concepts that we have discussed today. Today we got the introduction to default routing, and then later we have explored dynamic routing protocol, which is a routing information protocol, right? I have a task for you all, which you can try, which will help you in practicing rep. And this task is going to be really interesting one. So we'll take 4 routers like this, and we'll connect 4 LAN networks like this. Some end devices like this, here, 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 and here. And we will connect all of them together. Now, Michael, you can pay attention as you had question how to add a module. Now I will need an additional port to make the connectivity with the switch. Otherwise, I'll get this error. The cable cannot be connected to the port. So I will click on my router. I will turn it off. I will add NM2FE, and then I will start my router again. After that, if I make a cable connection, it will get connected, right? Similarly, on the all other routers also, I will have to add these 2 additional ports to make the connectivity with the switch. So I'll shut down, I'll add the module, and then I'll start the router again. Now it's time to connect the cables. So I'll connect my PC with a switch, then my router, again, something like this, and like this. Assume that this is R1, this is R2, this is R3, and this is R4. So you select the cable while pressing the control key, and then you can use the cabling option for multiple times. The network for R1 is 192.168.1.0/24. Similarly, the network for R2 is 2.0/24. Network for R3 is 3.0/24. And R4 is 4.0/24. Between R1 and R2, we will use the network 12.10.1.0/24. Between R2 and R3, we will use 23.10.1.0/24. Between R3 and R4, we'll make it 34.10.1.0/24. And R1 and R4 will make 14.10.1.0/24. This is your network topology, and you have to configure it with your RIP protocol that we have learned today. Okay. This is a task for you all that you have to try by yourself. Simply start with IP configs, then put the DHCP configs, and third step would be configuring RIP. I've pasted the topology so that you can copy and create the same at your end. You can get it from the same link. And if it has crashed, then you can just try to reopen it. It should work fine. And with that, that's all what we had to discuss today. So thank you so much. I hope you enjoyed the class and got to learn out of it. And if you are liking the training, if you are liking the delivery, if you are enjoying these sessions, then I have pinned the message or the link for the feedback. I would really appreciate if you guys can share your experiences there. Regarding the recordings, guys, it is not available for this session and will be available later on after we have completed the training. But if you wish to learn CCNA through a recorded video, then there is already a recorded playlist uploaded on the PyNet Labs YouTube channel. So Abdul or anyone who is interested in revising some topic can also check those YouTube videos and you will get the understanding there. Thank you guys. Take care. Bye bye. And the message is pinned. If anyone wishes to share your feedback, there is the link in the pinned message. You guys can share it there. I'll see you all tomorrow at the same time where we'll discuss about another amazing protocol called EIGRP. So let's see how that goes. Till then, take care. Bye bye. Enjoy your day.